Okay guys, we are doing a little demonstration here to help us figure out this weird phenomenon that I just pointed out to you in the previous slide, where the outer and inner core are made of the same thing, but they have different densities. This is very strange, right? So in order to illustrate how this could even be possible, I have here some bread. So this was 4 slices of bread. 1, 2, 3, 4. I just cut the corners off to make them nice and square, because what I'm going to do here is, can you see this? I'm going to take the mass of this little cube of bread that I have created. I'm going to measure its volume, and then I'm going to calculate its density from that data. Then I'm going to do something very mysterious to this bread. It's going to be great. And then I'm going to take its mass again, take its volume again, and recalculate its density. Okay, so I have a before and after with these 3 values using the same material. 4 slices of nicely trimmed bread. The only reason I trimmed them is because it's much easier to measure the volume of something if it has straight sides. Anyway, we'll get to that. Let's start by taking its mass. So my scale is over here. You cannot see it, but it measures in grams, just like the unit that you've been using. And these 4 slices of bread that have been trimmed down end up weighing about 2.29 grams. So I've written that down on my little worksheet here that I made just for you guys. That is the mass. Now, to calculate the volume, hopefully you remember that volume is length times width times height. So I'm simply going to measure the sides of my bread. Using centimeters, of course, because scientists never use inches. We don't like them. So this is about 8 centimeters by about 6 centimeters. And the height is approximately 5 centimeters. 8 by 6 by 5. So in order to calculate the volume, all I have to do is multiply those together. So with my calculator, 8 times 6 times 5 is 240 centimeters cubed. Okay? So all I need now is the density. Now at this point, I think you guys have calculated density enough to remember that it's simply mass divided by volume. So let us take our mass, which is 2.29 grams, and divide it by the volume, which is 240 centimeters cubed. And the density is then, whew, that is a low density. There's some zeros before we even get to numbers. So let's write that down as 0.0095 grams per centimeter cubed. And there it is. And hopefully you remember too that centimeters cubed and milliliters are exactly the same. So I could have written this as well as grams per milliliter, which is the unit that you guys have been using on your worksheets. Okay, now comes the fun part. I am going to do something mysterious to these breads here and take these measurements again. Remember that we're trying to relate this to the core of the planet, right? The outer core and the inner core are made of the same stuff, but they have different densities. So the question is, can I do something to this bread to change its density? And in order to help me, I have one of my very favorite books ever. It is Harry Potter and the Half-Blood Prince. Okay, so I'm going to use this much as we might use our physics textbooks of amazingness, but I'm at home, so I don't have a physics textbook of amazingness. I have Harry Potter. So without further ado, I am going to squish this bread. I'm going to squish it very, very nicely. I'm going to exert as much pressure as I possibly can onto this bread. Make sure it's nice and squished. Whew. Well, it definitely looks a little different, right? I have created a very interesting pancake of bread. Now, has the composition of this bread changed? Definitely not, right? This is still bread, okay? So I am going to fill out my little after column here to see what's happened to my bread, okay? So weighing it again on my scale over here, making sure it's all cleared out. The mass comes out to be almost exactly the same, 2.28 grams. So it changed basically by nothing, and I would attribute this to just that my scale's not all that great. We should note that as this bread got squished, it's not actually losing any of its mass, right? So there's its mass. Now its volume is definitely going to have changed. Volume is how much space something takes up. And this bread definitely isn't taking up as much space as it was before I squished it. So I'm going to kind of squish it. It's not very rectangle anymore, but it'll have to do. This will be an approximation. It'll work. So the volume works out to be about 9.5 centimeters times 6.5 centimeters times approximately 1 centimeter. So if we do our math here, that is 9.5 times 6.5 times 1, and that works out to give us a volume of 61.8 approximately. 61.8 centimeters cubed. That's way, way different. Before I squished it, it had a volume of 240 cubic centimeters. Now its volume has dropped down to 61.8 cubic centimeters. That's like, what, a third or a fourth of the volume that it was before? This is some very squishy bread. So let's figure out our density then. It is the mass, 2.28, divided by the volume, which is 61.8. So let's do that. 2.28 divided by 61.8. And the density works out to be something extremely different than before. 0.0369 is what I'm going to write it down as. 0.0369 grams per centimeter cubed. Look at the difference here. Before I squished the bread, it had a density of 0.0095 grams per centimeter cubed. After I squished it, its density has gone up to 0.0369 grams per centimeter cubed. That is a pretty significant increase. And all I did to this bread was exert pressure on it. It's the very same material, but it underwent more pressure. Okay, so you're going to use this to finish up that little worksheet. Best of luck.